All right, guys, so this is our last example. Just going to show you a repeated measures design here. Repeated measures means we could use different levels of a treatment on an individual at a given time. We're going to look at another example from your text, looking at the milliseconds between a light flashing and reaction of a pupil. And the eye was tested at 4 different powers. So what we're going to do is we're going to treat power as a fixed effects. We're going to treat a subject as a random effect. And then we're going to have a subject eye random effect. Because if we test, if we just look at the data set here, this will explain a lot more than my words can right now. If you take a look, you're going to see acuity, which is the reaction time. You're going to see the power it was on, the eye it was on, and the subject. So what you start to see is there's an effect of the eye. One eye could be stronger than the next based on a given subject. So it's not just an eye effect, it's a subject eye effect. My right eye is my strong eye. Your left eye could be yours. And your right eye could be stronger than mine if your right eye is your strongest. All these different things come into play. So what we're going to do is we're just going to count for them with random effects. It basically says the mean doesn't matter so much for every individual, though we can estimate it for the individuals in our population. But what we're more interested about is the variation it brings into play on the response. Will it help us account for this variation, right? So what I'm going to do is I'm going to run this model, and we're going to take a look. And here's what we get. All of a sudden you start to see, here's what we have. Here's our fixed effects. There's the power coefficients. We see the acuity comes up. Here it is. And here's the interaction between, or here's the random effects for subject eye and subject. Now, if you take a look at this, what you're able to do is you're able to go in and get the intra-class correlation and all those different things. But now let's just say we want to test for the fixed effect power to see if power is actually useful here. There's a lot of different ways to do this. There's a lot of different models. There's the KR model comparison test, which we talk about a little bit. If you come in, what it comes out and does is it gives you a p-value. Basically, it says, does power matter? Do you actually need power in there to account for anything variation-wise? So there's a lot of different tests you can do. Again, you can just do model comparison with AIC. If we did AIC between model 6 and 7 here, so do M6, M7, or summary M6, summary M7. All of a sudden you start to see, M6 is better based on AIC criterion, but we have hypothesis tests to go that way. Really, it comes down to, pick your poison, pick what you want there. These random effects, you can come in and you can take a look at and see what's going on here. And see how it all works out. If we're going to look at the interclass correlation for subject just to see what's going on there, we see there's 0.44. For same subject on the same eye, it's 0.65. So there's a lot of different things going on here. But really what it comes down to is I wanted to expose you to these type of models just so you can see a little bit of what's going on in advance. This will be the last time we talk about mixed effects models, other than when we get into maximum likelihood a little bit. We'll write down the model so you can, again, see it from a theoretical point of view to see why it's there and what it's doing. But I wanted to expose this to you because this is stuff that can come up if you do get into a position where, hypothesis testing is all you do. Typically in analytics right now, there's more of a move towards predictive and prescriptive analytics more than the traditional hypothesis testing stuff. So if you guys need anything, let me know. We're going to move on to a different topic now. All right, let me know.